Hello everyone, this is Isha Kumari from Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Artificial Intelligence, and today I'm going to talk on the topic operating system structure. So the contents are as followed. First introduction, then system components, system calls, how components fit together, virtual machine, and then conclusion. So the introduction, what is operating system structure? Operating system structure refers to the way an operating system is organized and designed to manage the resources of a computer and provide a platform for running applications. The structure of an operating system determines how different components interact and cooperate to fulfill their respective roles. These are various elements within an operating system that work together to facilitate its functionality and enable users to interact with the computer efficiently. Operating system design and features are constantly evolving with technological advancements, and these trends and innovations may continue to shape the future of operating system. So the next is system components. So here are the pieces of the system we'll be looking at: process management, main memory management, file management, input output system management, secondary management, networking, protection system, command interpreter system. So process management, a process is a program in execution, means a program is passive, a process is active. So a process has resources, CPU time, files, and attributes that must be managed. Management of processes includes process scheduling, as in priority time management, etc. Creation, termination, block, unblock, synchronization, communication, deadlock handling, and debugging. So memory management, allocation, deallocation for processes, files, input and output, maintenance of several processes at a time, keep track of who's using what memory, movement of process memory to and from secondary storage. So then file management, a file is a collection of related information defined by its creator. Commonly, files represent programs, both source and object forms, and data. This is the definition of file. And then the operating system is responsible for the following activities in connection with file management, such as file creation and deletion, directory creation and deletion, support of primitives for manipulating files and directories, mapping files onto secondary storage, file backup on stable, non-volatile storage media. So input output management, buffering caching system, generic device driver code, drivers for each device, translate read write request into disk position commands. So now secondary storage management, disks, tapes, opticals, free space management, storage allocation, what data goes where on disk scheduling. So now networking, communication system between distributed processors, getting information about files, processors, etc. on a remote machine, can use either a message passing or a shared memory model. So protection of files, memory, CPU, etc. means controlling of accesses depends on the attributes of the file and users. System program, command interpreters, program that accepts control statement, shell GUI interface, etc. Compilers, linkers, communication, etc. So now we'll be looking at system tailoring. Modifying the operating system program for a particular machine, the goal is to include all the necessary pieces but not too many extra ones. Typically, a system can support many possible devices, but any one installation has only a few of these possibilities. Plug and play allows for detection of devices and automatic inclusion of the code necessary to drive these devices. A sysgen is usually a link of many OS routines modules in order to produce an executable containing the code to run the drivers. So now system calls. So A system call is the main way a user program interacts with the operating system. So here we can see a diagram which explains what is a system call and how it works, and how the user and the operating system interacts. The user interacts with the operating system with the help of a system call. Uh, mm, so how a system call works: first, obtain access to system space, do parameter validation, system resource collection, logs on structure. Then ask device system for requested item, suspend waiting for device, then interrupt making this thread ready to run, wrap up, return to user. And here is a detailed diagram explaining how a system call works, where we can see step by step how the system is working. So two ways of passing data between programs. Here is a detailed diagram, and here we can see message passing and shared memory, where there is process A, process B, kernel, and how the memory is shared and how the data is passed between the two programs. So here are examples of various system calls where we can see different files, their descriptions. So now how an input system is put together. A simple structure example of MS-DOS. So application programming, then resident system programming, then MS-DOS drivers, which is then connected to ROM, BIOS device drivers. So this BIOS device drivers and ROM is also connected to application programming and resident system programming. So here is a layered structure, example of Windows 2000, where we can see system services, then Windows MGR and GDI, VM manager, process manager, security reference monitor, and graphics device drivers, Windows 2000 kernel, input output manager, and at last there is a hardware abstraction layer, HAL. So here is a layered structure, example of Unix, the user shells and commands, compilers and interpreter system libraries. Signals terminal handling, character input and output system terminal drivers, file system swapping, block input and output system disk and tape drivers, CPU scheduling, page placement and demand paging, virtual memory, terminal controllers, terminal controllers, device controller, disk and tapes, memory controllers, physical memory. So now virtual machine. In a virtual machine, each process seems to execute on its own processor while its own memory devices, etc. The resources of the physical machine are shared. Virtual devices are sliced out of the physical ones. Virtual disks are subset of physical ones, useful for running different operating systems simultaneously on the same machine. Protection is excellent, but no sharing is possible. Virtual privileged instructions are trapped. So here physical users are virtual user and virtual machine, and physical machine is monitor mode. And so here is an example of virtual machine, and we can see how processors, kernel, hardware, virtual machine 1, 2, 3, these all work. And then physical user is DOS application, BIOS drivers, and physical machine is Windows XP. This is an example of MS-DOS on top of Windows XP. So now an example of Java Virtual Machine. The Java Virtual Machine allows Java code to be portable between various hardware and OS platforms. And here is a diagram how Java program class files is shifted to class loaders, then Java interpreters, then Java API class files, host system. And finally, the conclusion. An operating system is system software that manages a computer's hardware and software resources and provides common services for computer programs. It is responsible for allocating resources such as the central processing unit (CPU), computer memory, file storage, input-output devices, and network connections among various programs. The primary tasks of an operating system include scheduling resource used to avoid conflicts and interference between programs and providing a platform for the execution of application. One critical task for modern operating system is the allocation of CPU time to each process. Each process is a given limited time to use the CPU, after which it must relinquish control and wait for its next turn. This process switching incurs some overhead which the operating system must handle efficiently while ensuring the protection of data belonging to different processes. Operating systems are found in various devices, including personal computers, smartphones, servers, and even embedded systems controlling applications. They can be classified based on their capabilities, such as single tasking or multitasking system, single user or multi-user system, distributed system, and embedded system. As of today's date, Microsoft Windows dominates the general purpose personal computer operating system market, followed by Mac OS and Linux.